Hello everyone, this is Akshaya Bitla and today I'm presenting you my project title Hybrid Greedy and Dynamic Programming Approach for Smart Parking Space Allocation. And this work is a part of CMP7002 module, which is Algorithm Design and Analysis. So, one of the major challenges in modern urban mobility, the real-time parking allocation. So let's go through the agenda for today's presentation. And I will begin by explaining the background of the problem, like why it is efficient for parking systems are important today. And then I will walk through a like short literature review and highlight the current gaps between them. And after that, I will introduce the proposed hybrid solution where greedy and dynamic programming algorithms work together. Finally, I will conclude the key takeaways and possible future enhancements. And with the introduction part, like with urban population increasing, the number of vehicles have grown dramatically. This results like for parking car, we need to spend some time for searching. So and it also have heavier traffic congestion and unnecessary fuel consumption. So the core problem is how to allocate parking spaces efficiently to incoming vehicles in real time. Like a good parking allocation system needs to minimize search and waiting time to reduce congestion and minimize space utilization and adapt quickly as vehicles arrive and leave. So this project aims to provide such as an adaptable and efficient solution. Literature and review, like several approaches have been explored in research. Firstly, greedy methods are fast because they take the locally optional choice, such as assigning the nearest available slot. However, during the peak times or when the multiple vehicles arrive, this may lead to like poor global outcomes. Like second is the optimization methods. Linear programming can provide an optional solution, but they are like heavy. So this makes them unsuitable for real-time systems where quick decisions are required. From the literature, there is a clear gap, like there is no hybrid model that balances speed and global optimally while handling. So the real-time and large-scale scenarios. So this gap leads to our proposal solution. And then the proposal solution. Our proposal solution system uses like a hybrid greedy and dynamic programming approach. The dynamic and greedy component is used like when parking the system is highly and lightly loaded. For example, when one vehicle arrives at time, it assigns the nearest available slot quickly and efficiently. The dynamic programming component activates during peak load or when the batch arrives where multiple vehicles enter simultaneously. So the DP algorithm evaluates multiple combinations to find the optimal group allocation. The system continuously updates parking which occupies in real time. So the scales to multiply, which are like parking lots and switches between the greedy and DP based on the current traffic load. So this gives us like both speed and near optimal allocation performance. And next, like this is the block diagram like for smart parking allocation system. Like this block diagram visualize how the system operates. Like incoming vehicle are first analyzed to detect whether it is low load or high load situation. If it's like single arrival, the system uses the greedy allocator. If there are a batch arrival, the request is forwarded to DP allocator. Then the system updates the parking database and returns the assigned slots to the vehicles. So this structured flowchart ensures the system remains responsive and efficient. And next, this is the flowchart. And this flowchart breaks down the like decision making process step by step. It starts with like continuously monitoring the vehicles while they are arriving. Based on the number of vehicles incoming, they are given a movement that the algorithm decides whether to give it to apply greedy or DP. After computing like assignments, the system updates space availability and waits for the next vehicle or batch to arrive. Then it ensures that the feedback of the loop that keeps the system dynamic and real time. And this is a conclusion and future work. To summarize, the parking allocation continues to a challenging issue in modern cities. Existing situations, solutions either favor speed or optimality, but not both. So our hybrid greedy plus DP method aims to bridge the gap by combining fast decision making with a global optimization. In future, this work can be extended with IoT sensors for real-time occupation detection, uh, or machine learning for predicting peak hours, and stimulations for multi IoT like city-wide parking networks. So this is the future enhancements would make the system even like more accurate and scalable. So that's it. And these are the like references that provided the foundational studies for the project, covering areas such as smart parking algorithms, greedy methods, and optimization methods. So, like they helped me guide the development of the proposed hybrid approach. And thank you for listening.